and which type of element we need to place. So we're missing the foundation family. We're gonna go for the structure, isolated foundation. It says it's not longer loaded. We can select just a basic one that it's the structural letter is English. Foundations which are fully rectangular. We need to change it because that's just gonna be the basic element. Foundation. That's just the generic foundation. But we want to have a mixed type of element. So the biggest ones we have, it's the little ones, these ones. 1,200. So I'm gonna duplicate the family. Put it here. Cellular. Called Learning Project. Have different types. So what I want that is that the framings have the size and they're also contained between the elements I'm getting. So I have 600, the bigger one is 800. So for doing that, we just need to get the element, call it duplicate, now let's rename. The first one is gonna be 100. So it's actually gonna hold for elements in between. So that's a big one. Also duplicate it. Make another one that it's 800 by 800. 800. Actually, if we want this to be created depending on the requirements we have on the combinations, the only thing we need to do is do the same thing we have done with the structural columns with the framings. So I'm just gonna copy this. Structural framings. It's called the reference level. And we want to know specifically where those elements are being at because we want our model to solve the requirements it has for each particular of this Peter Hammond. So let's say it's giving us different values. We need to make them compose. So for getting all those values, I'm going to use the get location of both items. That's going to show up something like this. Actually, because they are not sorted out. So yeah, so we need to sort it out first. This level, ratio, shift. So that those values are already being placed properly. Index of. Click item index. Now we can have this one. Yeah. So we were also talking about having the type file name. So we know which elements are being set up from here. So if the type is having the height, see the family is having the height from the age, and also ask for age, just age, with the measurement. So been selected. Yeah, because you need a height. In the case of columns, it doesn't matter because we want to know which one is being intersected with. So therefore we have the lines and location, getting the first item, getting the other location point curves. So we just need those intersect. Again, same function we did when we were trying to find how much was for each column. Lacing cross product. Parentheses of true. Give me the values. Then we can have the get iterate index. Then we just need to have the complete height. So we can go for the maximum algebra. On the other side, we have the columns. For the columns, we're having a type that it's called P and page. You can use it from here. It's element type, D parameter and H parameter. Those are the values from the columns. One side or the other one. List join. Because we want to make the two elements be together. Transpose. And with that is giving us as dot please join this script. There we go, also ask for the maximum item. We can make an A. Now we need to mix because we need to have 28 values of 20 values, so it comes to 20 at the end with the other 20. And with that we can do an A plus underscore plus B. Because we want to find the unique items, we need to choose. So it's giving me these constraints, unique items. These 5 types of peers we need to have in order to work properly with the foundations we already have. So for doing that, we can just do a split, normal split. separator is what we call the underscore. So in separator, call it remember. And transpose. Now we can have it just as index A 0, index B 0. Turn these two values. A times 100. 1000 actually. 1000 actually. And we can call the name A plus X plus B plus X plus C plus space letters. So it's having A plus B plus C. Those are the names required. The only thing is that it needs to go to a string from object. Format with the decimals, format without formatting, without, yeah, number string without decimals. So that it looks better. Something like that. So those are the sizes we want to have on here. So instead of making those changes, what we're gonna do is we're gonna create a duplicate type. Duplicate. It's called duplicate element type. You need to have from our main list the types. It's called the here. It's on the foundations. Rename. So it's giving me these types. I'm going to select the first item. And we have the element type. It's the element type. The names we want to have them. So it's going to be a lacing long list. And then set parameter by name. Thinking that the parameters we have already subscribed. So we have this one, it's called width, length, and foundation thickness. So it's gonna be called width, length, and foundation thickness. So copying this one 3 times, with the parameter, that parameter, that parameter, and the values are gonna come from here. So we are having these are the foundation thicknesses, and the measurements from the column are gonna come the actual values. Did you check that the units are properly set? Yeah, point something. Okay. So if we run it, now what is gonna happen is that we will have multiple types of those pins. And check, now we have 16 by 16 by 70 by 60. All of those that we are requiring. Actually, if we go a little back, you can still delete the ones we're not using. These ones is deleted. Yeah. This ones is deleted. This box is not. So let's just place them where they belong. So we can read and check the other file, or we can use it just from here. The only problem with my file is that if we don't have any other reference types, it will duplicate the sizes. But it's not a problem because we're using it from the same spot. So we can go for the index of. Index of will get element from the list. Actually, it's the opposite way, is the list. Getting the element. So when we are asking it for the line up, here it's shown that the first item is empty. So we're getting into a cycle that it's not actually solving anything. So we need to make some pause on this. So I'm gonna close it. Because it cannot exist at the same time that it's already been created. Open it again. Run it. Yeah, now it's creating the types. It's fine. Now that we have it created, we're gonna save it. And save it again to 06 structure. This will create. The part that is no longer needed, what needs to happen is this one. It's duplicate the setting of elements because we no longer need that to be multiplied. And when we run, we can see that if those elements are being properly set, it's not pulling all the elements here rectangular. Yes. So now close it. Open it again. We have now the types. We have the unique values. So we can set as index of. Actually, the opposite way is this one. And the only thing missing here is to know which one of these is being matched, since we have a problems in moving. So we can get just by the size and the element. We're gonna ask for get parameter value by name. Value by name. It's called length. Yes. That's it. Foundation thickness. That's it. If we have a foundation thickness by this one, let's repeat the same coding convention that the other one. So we can have the proper order and an index of. about here element index. Get element index is generally use these indexes for these family types. So I will split it like that, and then if we have another get element index, we have the list and we have the item indexes. Now we know which family it replaces which spot. But what is missing is family instance. By look by point. There can be a point, it can be a point by location. We will go for the family instance by point and level because we want to make it properly. So we have these family types. The level they're gonna be bring, that is the first item of entities, which is the first level. And for the points, we're gonna use just the basic geometry. It's here back on the current stuff like this one. So it's run, now it's placed, and now all of these are following the pattern of the biggest element in place. Let me see. Oh, actually quite the spot. I was having some problems in there. So we check, we're gonna go Control Z. Saving this file, it's right. Going to the other one, the foundation creation. Perhaps we have the missing spot. We need the, okay, so we're using, this is the framing location type. Framing location is going at the end and the beginning. And at the beginning, this, it's framing needs to go at the end. This one needs to go at the beginning. That was my bad. And the width, this is the framing one. Need to go to here, and the other ones need to go to here and here. Run it. Reading all the types. Now we have too many types. Just gonna get one type. And again, that's gonna the bonus. Gonna save it. Open it again. Arms. Now it has all the values. And with that, you can run the other function. It's called the foundation, structure foundation creation. And this is both is reading, so we're using the length and the foundation thickness. So actually the foundation thickness goes at the end, this one goes at the beginning. Run it, it should find. Yeah, because we haven't changed this one, this is the column values. Yeah, the column values. For the bigger one, Mhm. So we're having here something that it's let me check. 0.75. This one is not 0.75. It's having some troubles reading the values. There was a this one was with a problem, so now it's following 0.75, 0.80, 60, 60, 70, 120. Now it fits perfectly because it's giving us the maximum size. It has the column, the height of the beams, and everything is fitting smoothly, depending to the requirements of the bigger family it's holding. Fix the column, it fits the frame, or it fits the other elements. Let's create a last script using the footings we have and the foundations we already created. So I'm gonna save this family again, this script. It's gonna be called 07 foundations foundation creation. So we're gonna need these settings as well. The only ones we're gonna pull from here is the structural foundations. Structural foundations that are already placed. And with that measurement, we're gonna get the other ones. So we have one component that is called elements by family name. It's really good because with this one, we can just use the family name from an element and it will tell us what is it called, rename. So I'm asking for the family, all the elements by family name to be called. Get rid of these ones. So if it's running properly, I'm just gonna close over again. Family name elements. That's it. You can ask for the get parameter value name. Have the parameter length. That's giving us which is the distance it has from one side and the other one. With that, we can also do the creation of the proper foundation settings at the end. So if we go for structure, we have isolated, we have already placed a footing rectangular, but the measurements are not the ones we want for this family. So I'm gonna go for footing rectangular, rename, calling it by its name. Rename, family types, just giving the first item. We're gonna leave the same thickness. The only ones we're gonna be modifying it's the other two values, that it's the width and length. So with these values, we're gonna have an 8 times 1.6. Unique items. We have 3 types that we require. So we can use the same process using the duplicate. Duplicate. Oh, a duplicate element type now blurred. It's fantastic. So we need to do a multiply or 1000 to get the value properly, creating these three values, then to a string, then without decimals, so that the meanings we're having is a times x plus b plus x plus c plus millimeters. Showing these ones, we can just place it the 160 because they're gonna have the same width. With those names, we can just need to get this one. Set parameter by name. The element type is the parameter, the element. Parameter name is gonna be length with the value of 1.2. And we can copy this one, but to duplicate. So the other parameter is called width. So that's gonna create the types. We already have the types. We can ask for the get location to make it much more simple. The location of the elements. And with the spot, just need to do a translate. I'm not sure if it's, let's see if it's been placed on the proper location. So we have the family instance by point and level to the point that will do the family types we're needing is ones index of please break index of internal index indexes the element type family type and then just the level base level. So we set the get parameter value in from the element level and we'll use the same reference. So if they are on a lower level, we need to check work. It says it's a problem with it's family type. Yeah, element type. Yeah, we don't need an element type, it's a family type. Duplicate element type, we duplicate element family duplicate. Duplicate element type. What's the problem? It's basically the same idea. As completed, it's creating family is the spot, so you just need to see, yeah, that's what I expected. It's not actually being placed on the spot we wanted, it's placed on the top of it. and the measurement needs to go down depends on the thickness. So we need to have as well another one that is gonna be called foundation thickness. The foundation thickness is part of the type and just giving us that thickness they need to go down, and then we can use a translate so that the element can go down. What it's doing the translate is just actually moving its vector by coordinates, pulling out a plus multiplied by -1 so that the value is going down. The vector just modify it from the point, the location geometry to go down. Yeah, now we have them down. We also have them bigger depending on which is the requirements for development. So let's say you can change instead of having it 1.6 to have it 2. We found the settings, we create the types, and we create these ones to be bigger. So they're actually following the same path, changing the types that it's using. 3 times. That's making them much popular. So, hope you like this course. Please remember all these ideas are helping this process to be developed. And as well, more than happy to help if you have any other questions or further creation requirements. Thank you very much and happy development.